someone in a certain way. Now, I really like the way that actually Marshall McLuhan talks about this. He's like, what is the value of artists? He said, artists show us how to ride with the punch rather than taking a knockout on the chin. So without these other kind of narratives and interpretations, we sort of take it in the chin. But artists help us kind of run with a more poetic flavor. And there's examples of that. And I'm not going to go through all of them. I think one that's clear in the room is bringing together Steve Jobs and Steve Wozniak. Apple, that kind of DNA really is formative to how the culture was shaped and how the thinking happened. And it really, the kind of technology and the poetry together were amazing. Now, even, as I mentioned, I've worked a lot with this group, Survival Research Labs, and I think about the kind of community there. Now, this is a space that does large-scale performances, so not only is it about sort of the machines and the sort of staging, but these are actual interesting kinematics, interesting kinds of ambulation. I know it looks like there's some kind of battle bot thing going on. That's not what's going on. There's actually some sort of scripted performance, but I think about it as, what would machines do if we weren't around? What would they really want to do? They might want to do these kinds of things, to sort of wander around and sort of poke at things. They don't want to be building stuff for us and doing different kinds of things. And in this space, there was also interesting explorations of technology, new input systems, new ways of controlling things, new ways of thinking about how to actually do different ambulations and interactions. And even though I spent time in sort of at Berkeley and at Intel, I also spent time with other groups trying to understand and collaborate with them on how technology could come a part of this space. Now, just to drive the point home a little bit more. So I think many of you probably recognize this individual. It's Mark Weiser. And he did many things in our field. Many of you maybe cited some of his work in your own papers today. The thing I'm going to draw out is, not just sort of helping coin the idea of ubiquitous computing, but he also, of course, brought us things like, he said, well, we're going to have these pads. Well, I think everybody's got their pad now. Or tab, sorry, it's my tab. He talked about pads. I don't need to tell you where the pads are now. And he talks about boards. And I don't know, Roy can tell us more than a lot of us stuff. But the reason I'm bringing this up is he was the director of CSL at Park, and he was leading a big vision, very sort of technical, scientific, and this is where we're going to go meta, because I'm going to show you a slide in this keynote of his keynote, okay? So he gave a keynote. They said, hey, Mark, can you come talk at WIST about this thing you're talking about, these invisible interfaces? You're talking about computers everywhere. I'm kind of getting it. Like, how's this all going to work? I said, okay, I'll come tell you about this. And this is one of his slides. I think this is slide 4 or 5. It says, here's how you do it. You start from arts and humanities. Okay? This is the most important part of the talk. That's code for it's on the final exam, just so you know. And there's other important things there. He talks about feminism. He talks about all kinds of sociology and phenomenology, anthropology. But I do want to draw out that here's someone who, he understands every bit of this technology. And he says, actually, we're missing a huge part of the discussion. We need to really think about arts and humanities. So hopefully I've convinced you about this different approach, and at least trying to bring together some of these different perspectives. I'm going to walk through a couple examples that are a little closer to some of the projects that I've had a chance to collaborate on, and then we'll have a little, hopefully, time to talk about this. And Nick mentioned citizen science. I want to talk a little bit about making, and then this idea that's cosmetic computing. So in terms of citizen science, I first want to say something about design. So a lot of the work that I do is in design, and we can have a separate, probably, I don't know if it's a coffee or wine or beer discussion about the definition of design. I'm just going to put this one up because I particularly like it. So Herb Simon says, everyone designs who devises courses of action aimed at changing existing situations into preferred ones. So that means you're definitely all designers. You have chosen your clothing. You have chosen your food. You have chosen lots of things this morning. You've already started designing today's day. Now, the reason I'm going to talk about this citizen science a little different is, as I think, again, Elizabeth pointed out quite well, that we often face engineering challenges, and we have a lot of training and tools to operationalize and address them. Sometimes we're faced with larger questions and challenges, things around healthcare, famine, education, refugees, the environment. The list is enormous. And these don't lend themselves towards traditional engineering approaches. You can't just say, oh, it applies so-and-so method, okay, good, solved, all right, optimal, proved. These are actually called wicked problems. And Horace Riddle defined these and sort of came up with this framework. He was in the College of Environmental Design at Berkeley, and he said, these are these more societal level problems, and they have all these embedded other messiness. So once you start to try to solve one, often other side problems result. They're really, every single one is unique. There's a lot of issues about how to address these. And the only thing I'd say is that at least using some design techniques, you can at least, I believe, start conversations towards solutions as well as engineering approaches. So I think there's a kind of a blend of those. So often in design, you have terms like this, problem solving. We're thinking about, the consumer, things like that. But in design research, you're often thinking about more of the terms on the right. So instead of problem solving, you're almost problem framing or problem making. So it's more interesting to come up with sometimes you result with more problems. In the service of industry, what about in the service of society? And I'm not saying that design doesn't do this in general, but how can we pivot the debate more towards designing for debate, designing for making us think, and citizens? And design research is this process of knowledge production that occurs through the act of design. So sometimes it doesn't have physical artifacts, sometimes it does, but not always. And there's a lot of different terms that are in this space: critical design, speculative design, reflective design, the list goes on. Critical making, that's a class I actually teach at Berkeley called critical making, design noir. And I want to just give a very high-level view of what's sort of going on conceptually. In general, we're at some present state, this is some future state. There's a set of all possible things that could happen, right? So just what's possible given laws of physics and sort of progress. The plausible is a little bit narrower, right? These are the things that are plausible. That's what we're probably going to get, And even inside of that, we have probable, right? We're going to get more smartwatches. We're going to get more, smaller mobile devices. Some of these things that are very probable, right? So we know we're getting those, and it's a sort of safe bet. What critical design lets us do is pivot out and think about preferred design, preferred things that might not be on that axis, okay? Now, what that also means is sometimes the things that result are very unusual. And in fact, when you experience them, you think, well, I don't ever want this product or this thing. But the idea is that by standing there and interacting with it, you suddenly realize, I see another design landscape. I see other opportunities. I maybe don't want this exact thing, but I'm glad I came here, because if I'd stayed over here and just done all the near-term sort of low-hanging fruit, I would have never found these other things. So I'll say a little bit about some of the work that we did in citizen science. And this group has had a lot of great work in that area, too. I mainly want to highlight that the actual form factors in the landscape that we worked with were trying to create a broad portfolio of projects. So you're all familiar with, and I know this community has their own great work in using mobile phones as these kind of supercomputer radio station with sensors, how to attach sensors, collect data, crowdsource them. So we've done a number of these projects in this space as well. I think one thing that's interesting is to think about it as citizen exploration. So I think what this taps into is our own childhood curiosity that we had about, what's that cool bug in our yard? Why is that weed growing in a certain way? So I think that same curiosity, somehow we've repressed it, but we're actually, we're all scientists, we're curious, and I think other people are very curious, and this idea of participation and asking questions is a very exciting landscape to engage with again. Now, again, a broad landscape of different projects that happen, things with devices and infrastructure. Mainly, I'm just going to highlight a couple. One of them is an early work on attaching sensors to the infrastructure. So this is actually city municipal vehicles and street sweepers that moved around the city and collected air quality data. This is at Intel. Now, another one was a project by a student of mine, Sun Young Kim, who looked at indoor air quality and particles. And much the same way you can tell, are your friends online, or what are they listening to, or what's going on, what's their status. Imagine you could see people's remote air quality. So kind of an odd experience. But strange things develop. People would sort of go, hey, what's going on over there? They go, yeah, I just burnt something on the stove, right? Or what, people realize, actually, a side effect which was not intended was 2 of the people in the study quit smoking. That was not part of this, but they suddenly realized that was really dramatic. There are statistically significant results that people improved their air quality in their homes. This is because in the home you can actually take action. It's very hard. It's much harder to engage with the kind of big urban environment. And of course, you're familiar with lots of products that kind of do this now, and many of you have done projects in this same space. But the other project was to think about, well, what if these actual sensors were owned by communities? And what if they actually were not sort of personally owned, but they were shared? There was a resource limitation on them, so you could attach them outside. And we looked at how parents or activists or bicyclists or even a homeless community would move these around. And to sort of, again, we see that one size doesn't fit all. People want to have very different narratives about what they talk about. They also, and I knew this was going to happen, and maybe you've had the same encounter with your own research, is anything that doesn't look exactly like maybe a mobile phone is assumed to be a bomb. And so a lot of confiscated devices, probably like some of you have had similar things. But it was interesting to try to have that discussion about, well, are we ready for ubiquitous computing? Maybe, maybe not. Some of what we thought about wearables, we thought about how you might wear these devices. So these are obviously strange interactions. You would walk into someone's house like, whoa, what's going on in here? Man, right? So the person becomes the sensor. So this is a little bit different interaction. I think most of us are used to this personal experience. You're looking on your device. And in fact, this is having a person become that sensor. We took that one step further and looked at, this is work that Stacy Kuznetsov did with me, where she looked at how you could actually have small, almost just, these are just little glowing balloons that have small little sensors attached to them around air quality. The point is that it drew people into a conversation, right? So people came in, what's that balloon? Like, we just hand it to them. And then they could sort of walk around there sort of, oh, I'm going to go put this at my house or by this school, or I want to leave it in this park. So people, again, could have this way of having narration about them. Now, the one thing through this whole process is we struggled a lot with what to sense, and many of you that have worked in the space have kind of had this, and really you kind of need to sense, at least in most of these landscapes, particles, right? So you really want to be sensing the particles in the air. So we messed around a lot with anyone that's worked in this area. There's lots of different particle sensors you can buy, from $5 to $5,000, and they pretty much work as you could imagine. The $5 ones don't, and the $5,000 ones do, but they're $5,000. And we thought, there's got to be another way to design this. So we put a little bit of an engineering effort into this, and we did a ton of testing to see, could you get something down to around, $40 or $50 kind of bill of material parts. And so we came up with a very small, lightweight, you could produce this for around $50, and mainly you could also 3D print these, and we put this as a sort of open source project. And you can even wear it. It's not a sort of sexy, cool watch, but it's just about the right form factor. Someone with a little bit more design sense could make it look a little bit better. But the idea is that you now could have something that you could really distribute, and it would measure the right quality of the air, which is these particles. So this is a project we did this at Chi a couple years ago. It's kind of a tail end of something that was bothering us for a long time. There wasn't really good sensing in that space, and we sort of put it against $4,000 equipment and got really good calibration and alignment. Now, the other thing was, because you could have this device have any different form factor, we started to say, well, what about a carabiner? Or what about something that clips on? Or what about in like a child's toy? Like, why, when you think about what's the first technology that some child encounters, like, oh, well, they saw my iPad or my phone or something like that. But we thought, what if they actually, their first technology was maybe things they already played with, but we somehow had just a very subtle way of them experiencing sensing. So one of them we made it's always a triptych, right? So we made an air explorer. So this is the airplane. It has an e-ink display, and it sort of changes face based, and it sort of lightly vibrates when it gets more particles. So you could just It's not supposed to say danger alert, run away. It's just maybe they would add that into their kind of gameplay. Similar to Water Explorer, you can suddenly start to realize this checks total dissolved solids in a bathtub or in a storm drain or in a lake or things like that. Just, I think all of us harken back to exploring our world again, and these are sort of what we call these explorers. So the Earth Explorer, same thing, but with soil. So let me move on to this exciting thing that really creates from this making. I think a lot of us have seen how making and this new making renaissance is upon us, where suddenly the threshold to actually design and fabricate things has come way down. And I particularly like this quote from President Barack Obama. He says, "The maker movement is a revolution that can help us create new jobs and industries for decades to come, and will create entire new industries that we can't yet imagine." And I think that's very true, and there's a way for us to think about how we can actually integrate new kinds of making. So again, I remind you, we're all familiar with certain fabrication techniques, but we've tried to think of different ways of making and different ways of broadening participation. As Nick mentioned in the intro, this is, there's a couple different spaces on campus where they are kind of academic maker spaces. This is the Citrus Invention Lab. We give the students a lot of caffeine. They move very quickly. They build very quickly. The main thing is we create an immediate atmosphere that this is a space. You don't sit in a row on your laptop. You're very hands-on. These are the kind of courses that we teach. I'll just brush through a couple projects. These are like two and a half week projects, so these are not really deep, but it gives you a broad range of what students often do. This was a spice printer. A student wanted to make spices when they cooked, and so this prints the spices. Okay, you had a little app, so you could say, I want that special spice that my mother used or my father used, and it would just come out. This is students that figured out that you could actually have an ephemeral graffiti by spraying on moss. It would just grow out. You'd have a QR code, and then it would die off. And it was this sort of interesting way of putting digital material onto organic surfaces and growing things. That's pretty unusual. And I think secretly they liked this project because it actually involved beer, because you needed some beer to get this to kind of grow correctly. Some feel like projects that might exist in this landscape. This was the sort of citizen science project some students did around bicyclists and air quality, so that harkens back to the previous discussion around citizen science. Some of them are very poetic. This was a project that was literally a sort of called Free Speaker. It's a spoken word poetry boombox. So the student thought, people don't listen to spoken word poetry. How would you tune into spoken word poetry? So I should say this class and others, it's about a mix of half engineering and half students from humanities that come in. This is a student that wanted to make a skirt that pushed away people when they got too close. So as you get really close, sort of pushes them away. They were bothered by, people on BART and other things who would just say, no, you need to get away. This is a project called Spark that was a scarf that allowed you to understand and experience when and where sexual harassment had occurred. So as you wore it, it's very much a kind of mobile device. As you wore this, you would actually have it would sort of heat up on the back of your neck, and you would feel sensations and be reminded of what had happened in different parts of the city or the campus. Some are technically quasi-legal. I should say that some of the projects from this class do get confiscated by the police. This one did not. This was a project a student wanted to design basically when the parking meter maid is coming and the flashing light is coming down, beep, we're coming to ticket you, detects that and drops a coin in the slot just in time to save you from a ticket. 3D printed, small kind of interactive electronics. And then I just had, this is sort of hot off the press because the class is in session this semester, and the first assignment I said is rethink objects from a protest. Okay, you can tell where this is coming from, but the idea was to rethink, how interactive objects and wearable computing and mobile devices could play new roles in this kind of wearable landscape. So this is, and these are, I don't know, these just came in like last week, but one of them was an idea that, and it has some flaws, so we can talk about that. But the idea was, one thing is you can't tell collectively who all the people are that are part of the movement. So they decided to make this way to kind of come together. When you touch each other, then you're all sort of definitely part of the group, and there's other people that are not part of the group, and so they would be identified as such. So very kind of simple technology, but people can prototype and make these nice little stories. I know they look a little bit like they're all in black and it's a little nemesis, but the other one was thinking about signage in protests. And so the idea is that people were using these signs. They had to do ethnographic studies at protests, and that they thought using this torch metaphor, they actually could record sound, and then it would sort of play back a kind of rhythm of the sound, and you would get a sense of that. And the idea was that you would also be able to take this with you, and you'd have it back at your home or your apartment or your office, and it would remind you by having this sort of flickering that, in fact, you remember you were at that protest and you were going to take some action, and now you're kind of you're not engaged with the day of protest, but there's this kind of reminder of the protest. So we try to think broadly about these things. We also have a really fantastic new building at Berkeley. So, and this is what it looks like when it rains. See, put the rain in there for you. This is a Jacobs Institute for Design Innovation, and it's a 24,000 square foot building that's all focused, and this is largely driven by a gift from Paul Jacobs from Qualcomm. And the motivation, and he's very clear about this, he said this is to bring together art and engineering. And he says them in that order specifically, and it's really got a lot of those similar kinds of landscapes that I mentioned before. So it's large spaces, studio spaces, hands-on making, prototyping, design thinking, all the sort of laser cutters, 3D printers you would imagine, reinterpreting the classroom as much more a sort of studio hands-on space. Sometimes it doesn't even look like this. I one time decided to get rid of the tables and make a campfire in the middle with a little heat lamp. We brought marshmallows, we roasted them, we projected slides on the ceiling, we hung out on rugs, and we had class that day. So often rethinking what can actually happen and getting students off of their normal thinking about classroom and education. But we also do some research in this making space, and some of it is trying to rethink how you make objects. So if you think about 3D printing, one of the advantages is everything is kind of exactly the same. That's kind of a nice feature. But it also means that everything's exactly the same. And so a project that one of my students, Cesar Torres, did was think about how could you layer other data sets on top of these models so that you could actually create things that had other data sets such that they would always be printed a little bit differently. So if I sent you a file, it would actually not print the same as when I printed it because maybe it's being driven by title information or something else. And so there's a lot of different objects people made as part of a study. This was at, I think it was at WIST a couple years ago. And this was people, actually this one was interesting because he said the subject said things that they love on this one and they screamed things they hate on this one. And so that's what's driving those two designs. So this is another example where the campanile, so a symbol that's at UC Berkeley. This is sort of the canonical view of what it looks like. But the one on the right is actually overlaid with the data set from Mario Savio's speech, a free speech about kind of throwing yourselves onto the gears of the machine if it's not working. And so I kind of claim this one's a more authentic representation of Berkeley, even though it might look a little bit disrupted. Similarly, when you're doing these designs, you're often thinking about what the appearance is, the outside form. And so Cesar and others also looked at, well, what if we could control the internal design space so we can have compliance in certain directions? We can actually change the center of mass so that we can actually change the way it might behave. Or we could change the textures of it. So these are just different ways to play with material. Now, how many of you played with Shrinky Dinks? This is like a bygone child thing, but that's pre-stretched polystyrene. And we realized it was a good tool. This is Joanne Lowe did this project looking at how you could actually change and use that material, because when you heat it up, it actually shrinks down and it hardens. So what it means is now you can actually sketch circuits, but when you heat them up, all these good properties happen. It shrinks, it gets more rigid, and all of the parts sort of that you would do, say, through-hole components will sort of be aligned, and you get better conductive traces because all of the conductive traces are sort of shrunken down. So one other thing about this one is this, usually if you think about when we design something, we say, make your circuit, and then make your 3D model and put the circuit in the model, and that's your final object. This is saying, what if the circuit is the final form? So what if it is actually the sort of final form and it becomes part of the actual design. So we've also been looking a lot at hybrid materials. Many of you have probably played around with things like this, where you can actually have electronics embedded with structural material. This is the voxelate printer, which does this. And one of our students, Kevin Tan, has basically looked at how you can make components like capacitors. Obviously, you can make resistors, and you can also make inductors, things like that. And the idea was to print your own sort of dials and knobs and things. And the interesting thing is you can actually print the capacitor, and you can print different mechanical properties of how you want dials to feel and behave. Now, yes, you can go order these things, and you can put them into your design, but it's really compelling to just say print and just get exactly what you want and say, no, I'm going to change it a little bit more and print, and you get another one. So you can iterate really quickly using that design space. We also think about when we make a model and we have some final fabricated object, that is the final piece, and we hold it up and say, this is what we made. But we also thought about, what if the thing you make is a proxy to help you make the thing? So in some sense, a kind of specialized jig. And so Cesar looked at how you could actually design something for, in this case, people that did different kinds of jewelry and artisans and artists, and say, what if you could actually scaffold them into being able to design things they wouldn't normally be able to by taking the design, being able to computationally figure out jigs and sort of proxies to make final designs. More recently, Cesar has looked at, what if the material you're designing with is actually not the physical object again, so this is light. So he actually has a project on illumination aesthetics, thinking about how light can be a material, how you can design with light in a very compelling way. This is just going to Kai. We just found out a couple days ago this got a Best Paper Award for that, so I'm really proud of him for that. And finally, in this maker space, we end up, if you can see, there's lots of things with different kinds of materials. So there's, we have things that we're drawing kind of conductive ink on paper. I didn't show you all the things with tape, but many of you maybe work with copper tape, conductive thread, different kinds of conductive paints. And so we designed this tool which lets you actually just sketch things, so very easy to sort of sketch designs, and then it handles all the complicated things about resistive values and how to kind of connect circuits using these very important material properties about how the tape works or the thread works, and so it handles the constraints of that and then gives you instructions on how to build these things. All these projects are supposed to invite in broader participation into making beyond just the standard make big CAD model, ship STL, print, come back in 900 hours and get your object. It's sort of, how can these be more interactive? How can these scaffold people into more making and building? All right, so I want to have this discussion now about this idea of cosmetic computing. So this is very akin to things in the wearable domain, but I think there's a really interesting way to hopefully take a new stance on where we can go with wearable and wearable electronics. As we know, there's a lot of phones, watches, lots of smart devices, Fitbits. The list goes on. Many of them are also here in the program. But one of the things is thinking about what other landscapes might emerge, and also can we use that as a social opportunity to change the discussion around sort of dress and wearables. And so I'll read this. It's a little long, but I want to read it because it kind of positions where we're thinking. So cosmetic computing is a vociferous expression of radical individuality and an opportunity for deviance from binary gender norms. So we're thinking, how can this really not be so constructed around one particular way to think about cosmetics? It's a catalyst towards an open, playful, and creative expression of individuality through wearable technologies. It's a liberation call across gender, race, and body types, leveraging the term cosmetics, originally meaning technique of dress. We envision how intentionally designed new wearables, specifically those that integrate with fashionable materials and overlays applied directly atop the skin or body, can and should empower individuals towards novel explorations of body and self-expression. Unlike many modern traditional cosmetics that are culturally laden with prescriptive social norms of required usage, or restrictive, sexually binary, and oppressive, we desire a new attitude and creative engagement with wearable technologies that can empower individuals with a more personal, playful, performative, and meaningful technique of dress. So what we're saying is maybe this is an opportunity to say, can we somehow take back some control from a lot of the kind of corporations and fashion media and say, actually, the stereotypes that you put onto a lot of society, maybe we can take this bit of technology and use it as an empowering tool to re-express ourselves and gain back some individuality and really be playful and creative with it, rather than, oh, this is only for people with a certain body type or people that are of a certain sexuality or something like that. So how can this really be not just, of course, it's a bit that's how does the technology work, what are the applications, we can talk about that. But I'd be really excited to think about how it won't just fit into a similar, consumer model. So I'm hopeful that we can go in a different direction. So, as I said, we're all familiar with these kinds of devices. Let's just say some things about wearables that we know that are sort of good opportunities. So they enable immediate access to body-based sensing, provide personal and glanceable interfaces, but they also, let's be conscious that they play a role in sort of fashion as well. They're so visible. They're not in our pockets or in our bags or things like that. They're actually, you see them. So they're actually things that you might actually care to change and design. Now, there's lots of challenges. Everyone in this room is clearly aware of these. Things like power. These are small devices. Where are you going to place them? Where are they appropriate socially? How do you actually interact with them? How are you going to program these things? How are they going to interoperate among devices? So start thinking about, am I wearing the right belt that's 2.0 compliant with talking to my smartwatch, that the button on my jacket pocket is also, how about my bow tie? That's not upgraded yet, right? So there's these nightmare scenarios you start to think about. Socially, how are you going to interact with them? And a lot of things, again, about function and fashion. Let's look at a couple examples. So let's talk about clothing for a minute. So this is a project Joanne Lowe and Lloyd Evendorf really led. And this was using technology from the Google Jacquard project. So it was in collaboration with them, thinking about how to use that technology in some different ways. And if you think about fashion, people wear things. You think, yeah, okay, whatever, I get it, people wear things. But these are often coded signifiers, right? A lot of you chose things based on coding, things that you have meanings or histories about or what you like. There's some conscious choice in those. And so we're thinking about how to keep that as part of the narrative. And as I said, Google, for those of you, I think many of you are probably familiar with the Google ATAP project. One of them, the Jacquard project, actually had these cotton wound insulated copper wires that you could use to actually send signals through. And so this was nice because you could actually have woven fabric that could function very much like a capacitive touch sensor, so you could imagine just moving over your clothing and things would happen. The variation that we took was to look at it as a way to do thermal heating. So we actually put thermochromic paint onto the onto the cotton that was wound around the copper wire. And so then we were able to get kind of non-emissive changes. So usually when we think, hey, my wearable clothing is sort of doing things, then you think, oh, it's lighting up. This is not lighting up. This is just changing the actual texture color. And this let us play with a lot of different ways of weaving and fabrics and clothing. And we started to sort of play around with different ways that you can control it. This is a little video to give you like an example. But the idea is that now your clothing, this is sort of sped up. So this is not, you're not running real-time video on these things. But you can change the appearance of your clothing or of textiles. So in this case, it's changing, little squares, or you could change stripes. So one thing to start thinking about is, right now, the clothing you have on is probably the clothing you're going to have for the rest of the day. But what if I said it would change throughout the day? Things might happen to create different experiences. So, maybe in the morning it looks like this, in the afternoon, later, right? Maybe you have different styles of dress, so you're changing the way it looks throughout the day. Maybe if people, like what you wear, it has more signifiers, so it's signaling something. There's also the kind of dark side. You can write on people and hack into them, right? Or you can sort of change someone's appearance in the middle of a game. So Suddenly that person's an outsider. Hey, wait, what? No, this is just, they hacked into me. The point is, thinking about clothing as a much more dynamic material, and I think many of us already think about that, but how will you program that? What will that experience be like, and how will that work? Let me move to another part of the body. I'll move to the largest organ, and that is the skin. So we've looked also at how the skin can be part of the interactive experience. This is a project that, again, Joanne Lowe did on scintillates, looking at how you could actually put electronics onto the skin. Now, a lot of people have been doing this recently, really amazing work from John Rogers and lots of others, so I don't mean to gloss over them. I want to mainly try to go back to this making philosophy, because what we did is, rather than having access to special fabrication labs and a $100,000 piece of equipment, we said, well, if you have a screen printer, a vinyl cutter, some conductive silver ink, and some temporary tattoo paper, we can show you a technique to actually design interesting tattoos. These are not them, but referencing kind of how tattoos are very visible and looking. But we can actually create interactive experiences around them. So we can do a couple different things. They can obviously be conductive. They can also be placed in different parts of the body. They're very thin, so on the order of about 36 microns. So they're very flexible. They are easy to wear. And you can see this from a picture there. And there's also, I mentioned all of these things. We have to think about the functionality, all the electronics, but also the fashionable. So how do they look? How can they be designed? And so this one has small little LEDs embedded into it. And the point is that now you can actually do capacitive sensing, so you can touch your skin. You can do strain gauges. And I'll show you a little video here. So this is Joanne's got a big kind of tattoo on her back. This is showing how the process works for doing sort of silk screening. And then you can play games by just tapping on your skin. We can do multi-layer. You can now touch your skin to trigger events. So I think most people in the room could imagine what happens here. Obviously, there's a little bit of smoke and mirrors because I'm not showing you that the battery issue is not totally resolved, but we have some ways to deal with that. Resistive, capacitive. We also have these strain gauges that you can put on your neck. You can send signals to people remotely. The little heartbeat going. And again, the challenge was, can we design something that's functional? It has to work, has to do something, but it's comfortable, so it fits with your natural skin and wrinkles, it's durable, and it's somehow aesthetically expressive. So back to this cosmetic computing theme, people can participate in their own designs. Now I'll give you just one or two more examples in this space. One of them is also looking at fingernails. So this is a place that I think there's been a lot of other research. People have been doing things with accelerometers and different kinds of sensing techniques. The thinking here was, one constraint was, let's try to design something that doesn't require you to sit around and plug in your fingernails to charge them all day and all night, right? I can't go, I'm still charging. Give me a couple more minutes. Just tell me where you're going, right? What kind of experience could you do with no battery, okay? So what we did is we looked at how standard inductive charges, things like NFC would work, and how you could actually have this thing called an alternail. And this is Christie's really been leading this work. And the idea is maybe not the most aesthetic. We do have a newer version, but this is an older picture of a prototype, so it's pretty big, but we can get this down a lot smaller. The idea is it has e-ink, so it has a bistable display, and it has this inductive charging. So now it means that you can actually, this is sort of a little bit better description of what's going on. But the point is that you can now, as you touch things that have this charging in them, and as you know, you can start to do that even away from chargers, but for the sake of this, you might touch, maybe as soon as you touch the doorknob here coming into the hotel, boom, says HotMobile, right? It's like, whoa, cool, I was at HotMobile, right? There's a lot of other things you can do beyond just these kind of fashionable things. You can tell as you touch things if, I don't know how many cookies you had, is the tool working correctly? Are you, the people that have touched this, is this maybe something that you need to know about the status of? But of course, you can also be touching your phone because it has NFC in it, so you can kind of download things, and then quickly I have little reminders on my fingers. All right. Let's talk about hair, because this is another landscape that we're interested in. I don't have any hair, so I will not be demoing this. I was going to bring a crazy wig, but it's too creepy. But hair is a really interesting point of interaction because people often touch their hair. It's very visible, and so we are exploring these ways that you can actually detect how and when you're touching your hair. So as you do gestures and pull or twist or kind of caress, that we can actually tell long strokes and different things that we can trigger, like sending messages, right? So this is like another discrete way to interact. Now, it's interesting to think about hair as an input device, but we're also thinking about hair as an output device. So this gets into, this is back to the wild and crazy ideas, which we'll lead into, but we are doing this. So we're looking at how to do color changing hair. So we're able to actually do that. This is Christy actually wearing some of the color changing hair. So you can put this into your real hair. This is just, I'm not subjecting her to like cutting all of her hair and doing all this stuff, but she can actually get your hair to change color. You can imagine this signifying lots of different things about, again, back to the clothing example. What if my hair and clothing were changing? I think this is a really exciting opportunity. We've also looked at ways to get the hair to actually change shape. So these are sort of some things we have in the lab where we're using SMA and some other technologies to get you, imagine your hair slightly changes, it's a little more frizzy, mad scientist hair. It's like not mad scientist hair. So I think there's a lot of interesting things that are in this space. Again, problems and challenges. How are you going to program these things? We're all sitting here going, yeah, here's how you design an app, and you say, look for these sensor values and do this particular action and read from the cloud. But again, what do you do when suddenly the alert, I need to get an alert, and it's like, I can't talk to your hair, the hair network is down, and it looks like the fingernails are offline, and the watch, like how do you program an application across this very disparate landscape of technology? How do you discover them? What's available? Again, I'm not wearing the right, belt today because it doesn't have the right, I/O mapping. Power, there are some ways I think we'll be able to address power, not today, but in very near term, and I think a lot of you in this mobile space look at this as well. Security, so people basically driving different applications across them. And again, this aesthetic electronics. How can the electronics be foregrounded to be really part of the fashion? So I'm going to end with just these sort of 10 kind of research stratagems, I'll call them, that I try to think about, and maybe they'll make sense to you, or you'll be able to sort of draw some inspiration from them. Use constraints. Okay, so technology isn't always the answer. Use less. Intentionally limit yourself sometimes. Question progress. So consider negative outcomes of technology, society, and progress, and what's being lost or what's going to have to be replaced. Sometimes that's a good thing, but sometimes just be aware of what's being lost. Maybe that's also a design or research opportunity. Celebrate the noir. So explore the unintended uses and possibilities of technology, of what might happen. Also, misuse technology. I think everyone in this room is probably an expert at doing this, but just to remind you, misuse or hack technology in its function, doing things the wrong way, sometimes gets you to a great outcome. Be seamful. So sometimes technology that you're working with doesn't work, you're out of Wi-Fi range, or it doesn't work when you're in a certain lighting environment. And rather than being discouraged that it's not working, that's a seam. That's a technology seam where something's not quite working right. But that could be an opportunity that maybe the experience changes, or there's a special part of the game that happens there. There's lots of these kind of opportunities. Bend stereotypes. So hopefully you've seen in this talk lots of examples of expanding the assumed roles of who's using a technology and who's supposed to be using it, and sort of look for ways to push back on that. I think now more than ever, given the political climate. Blend disparate contexts. So again, a lot of us, we might have, my lab's full of electronics and things that look pretty much what you'd expect, but hopefully we have organic things. We try to work with organic materials. We try to work with, fabrics. We try to work with the skin. We try to work with lots of things around very disparate contexts and blend them together. Be confident being different and offering an alternative viewpoint. Okay, so just sort of tactfully contrarian. Sometimes you might be the one giving that viewpoint and it feels very awkward, but I think, I love this again, back to this thing of the wild ideas. This is fantastic. So this is a point to sort of have that shine. Embrace problem making. And I think sometimes, this maybe happens more with I think, students, but I think all of us, where you have some outcome and you go, gosh, that didn't solve the problem at all. Now I've just got a bunch of more problems. Okay, time to throw that away and do something different. That could be really fascinating, to create more problems. Our community needs more problems. I know that sounds odd, but I think just helping define and articulate what they are is really important. And finally, read. Often there's a lot of things that people have done before us, and so learning who they are and what kind of work they did, what questions they asked. And so we're always playing catch up, even with the work that we're doing now. There's a lot of finding myself reading a lot about, fashion and things that I'm not usually used to reading, but really trying to find out what they're doing. So finally, I'll leave you with another quote from Barack Obama. So he recently, right before he left office, he said, the most important, we need not only the folks at MIT or Stanford or the National Institute for Health, I put Berkeley because obviously he left out Berkeley, I don't know what he was thinking, but also the mom in West Virginia tinkering with the 3D printer, the girl on the south side of Chicago learning to code, the dreamer in San Antonio seeking investors for his new app, the dad in North Dakota learning new skills so he can help lead the green revolution. That's how we will overcome the challenges we face, by unleashing the power of all of us for all of us. Not just for those of us who are fortunate, but for everyone. That means creating not just a quicker way to deliver takeout downtown, but also a system that distributes excess produce to communities where too many kids go to bed hungry. Not just inventing services that fill your car with gas, but also creating cars that don't need fossil fuel at all. And I think it's a really humbling message to think about the kind of impact I think this community can have. And it's a huge honor to be here with you today. Thank my students that did a lot of the work. So thank you again, Nick and Elizabeth. Sorry if I pulled you from coffee, but I don't know where we are.